Alrighty guys, let's go ahead and get started on these next set of notes. Today what we're going to be doing is solving absolute value functions, okay? Now, the definition of the absolute value, I went ahead and found a little bit more of a definition. It says that an absolute value is a number's distance from zero on the number line. The absolute value is always going to be positive, with that being said. Now, of course, that definition was just a little bit extra for some of you who wanted to know more about an absolute value, but it's not necessarily pertinent to the notes that we're doing today, okay? But what we are going to be doing today is we're going to be solving for x, because you'll notice here on these first three equations right here, we know that anything that gets plugged into the absolute value is going to be positive. So the absolute value of 5 is going to be 5. And if we take the absolute value of -5, well, like we just said, anything that goes inside the absolute value is always positive. So that'll be 5. But now when you get to the last one, like I said, we'll be solving for x, where you'll be given the y, and you'll be asked to say, alrighty, so what are the possibilities of x? Well, with that being said, we just got done saying that it has two possibilities. It could either be 5 or it could be -5, okay? It just really depends on what we end up solving for. So let's go ahead and actually get into an actual problem. Now, before we do that, we have to actually do some steps here, so that way we know what we're doing. Step number 1, what you're going to do is you're going to isolate the absolute value. Go back up a little bit. Value. Then step 2, what you're going to do is you're going to write two equations. Okay. And then step 3, you're going to go ahead and make the second one negative. Okay. And then you're going to solve for x after you do that. So those 3 steps are what we're going to adhere to. Now, of course, those 3 steps will make more sense as soon as we start chugging along. Now, this first one right here, what we're going to go ahead and do is we're going to ask ourselves, is the absolute value isolated? Now, what that means is there anything around him on the outside of the absolute value? It's okay if there's stuff on the inside, like that +4, that's okay. We just gotta make sure there's nothing around him. And in this case, there's nothing, right? So we can go ahead and get started. So the first thing we're gonna go ahead and do is we're going to do step 2, which is write 2 equations. So what I like to do is I like to split them down the middle, and that allows me to go ahead and do my equation on either side. So I've got my first one, my p plus 4 is equal to 1, and then I've got my p plus 4 now is equal to, now we said 2 equations, but we have to do step 3, which is make the second one negative. So we got to take this one and make it a -1, okay? And then we solve for x. So by solving for x over here, we subtract 4 on both sides, and we got p is equal to -3. And then we do the right-hand side, and we got p is equal to -5. Now, these right here are possible solutions, okay? We do need to go ahead and check our work, so that way we can ensure that these do work for the problem. So in order to check our work, we plug it back into the original equation, which was the absolute value of p plus 4 equals 1. We're not going to plug them into here. Do not plug them into these right here to see if they're going to work. You need to plug them in to this blue one, to the top one, okay? So here we go. So for the first one we found, we have the absolute value of -3 plus 4 is equal to 1. We solve for that, and that gives me absolute value of 1 is equal to 1, and it does check out. So this one's good to go. Now let's verify the other one. So we've got absolute value of -5 plus 4 equals 1. And then we're going to simplify, and we have -1, absolute value of -1 is equal to 1. Now, most people would actually say, oh, this isn't going to work, but that's not the case. Because remember, anything that goes into an absolute value is going to become positive. So we have actually a 1 equals 1, and this one does work as well. So we end up with 2 answers for number 1, okay? Got 2 solutions. Let's go ahead and take a look at the next one, okay? Same process. So we see whether or not it's isolated. It is, so we're going to go ahead and we're going to split it down the middle, and we write our first equation as is. But then we take the second one and we make it negative. Alrighty, now let's go ahead and solve for x. So we add 9 to both sides. That's going to give me 2x is equal to, I believe that's 24. And I'll get x is equal to 12. So that's one possibility. Then on the right hand side, I've got to add 9 again. 2x is equal to, now negative 15 plus 9, that's going to give us a negative 6. And so x is going to equal negative 3 when we divide by 2 on both sides. So here's another possibility. But remember, they're just possibilities. We do have to check our answers. So by doing so, we're plugging them once again into the blue, okay, plugging them into the original. So if I wanted to check, I'll do the first one. So I've got absolute value of 2 times 12 minus 9 is equal to 15. Well, 2 times 12 is 24 minus 9. Okay, that looks good. And then we might subtract 9 from 24, and that gives us the absolute value of 15. Now, of course, that one will check out. That one does work. So, boom, that one's good to go. But we still got to verify the other one, so let's do so. So I've got my absolute value of 2 times negative 3 minus 9 is equal to 15, okay? That's going to give me absolute value of negative 6 minus 9 is equal to 15. Now, negative 6 minus 19, that's going to give me a negative 6 minus 9 is going to give me a negative 15. And then when you take the absolute value of negative 15, that's going to give you a positive. So as you can see, we end up with 15 is equal to 15 still. Okay, so that is also a good answer. So once again, we have 2 solutions. Okay, let's go ahead and do one more example. Okay, you can do number 4, guys, for practice if you want. Just keep in mind, you can't really make 0 negative, so just keep that in mind when you're doing the example. You might only end up with 1 solution for number 4. Alrighty. For number 3, this one is a solid one. It allows us to use all the rules. First rule is to see whether or not it has the ability to be isolated. Well, this plus 2 right here is in our way. We got to go ahead and move him to the right-hand side. So in order to do so, we subtract. And so I'll go ahead and write my work over here so I have more space. I've got absolute value of 3 over 7 x minus 9 is equal to now 6, because I subtracted 2 to the other side. Now we're going to split it down the middle, and I have 3/7 x minus 9 is equal to 6, and 3/7 x minus 9 is equal to negative 6. Alrighty, so we add 9 to both sides on the left over here. And that's 3/7 x is equal to 15. Now, what we're going to go ahead and do is we're going to multiply by the reciprocal, okay, in order to get rid of the fraction. So that's multiplying by 7. Oh, my pen went out. 7/3 and 7/3. So these will divide to 1, and they'll go away. And so then we're left with x is equal to, now 15 times 7/3, well, 15 divided by 3 is 5. 5 times 7 is 35, so that should be 35. So that's a possibility. And now we're going to check the right-hand side. Same process, you add 9. So I have 3/7 x is equal to, now negative 6 plus 9, that should give us a positive 3. We're still multiplying. by the reciprocal. And so then we have x is equal to, now 3 divided by 3 is 1. 1 times 7, that's going to give us 7, okay? That's why we always say that these divide out to 1, guys, because if we had said anything other than, 1, some people say 0 or cancel out, and that's when students get into an issue. Alrighty, so now what we're going to do is we're going to check those answers that we just found. So we have, and then I guess I'll put a little divider right here, so that way. I've got 3/7, absolute value of 3/7 times 35 minus 9. Now, I'm not going to use the original. I know that that's what I've said in the past, but we're using the original. That was the equals 6, okay? So we have equals 6. That's the one we want to use, okay? And so when we solve for this one right here, 35 divided by 7 is going to be 5, and then 3 times 5 is 15. So we've got 15 minus 9 is equal to 6. And then 15 minus 9, that will be absolute value of 6. And of course, this one works out as well, okay? So that's a good answer. Now let's verify the other one. So the other one was 3/7 times, let me see here. It was 7, yeah, that's right. 7 minus 9 is equal to 6. So the 7s, of course, will divide out to 1, and you end up with 3 minus 9 is equal to 6. Well, 3 minus 9 is going to be -6, but that absolute value is going to take care of us and make him positive, and that answer works out as well. So now what we're going to do is we're going to shift gears and take a look at some possibilities where we'll solve for answers, but get this thing called an extraneous solution. Alrighty, hold tight. Alrighty guys, so here we go. So the next part is this thing called an extraneous root. Now, extraneous root is an apparent solution that must be rejected because it does not satisfy the original equation. So let's go ahead and dive into what that means. So what that means is you're going to solve for a value of x. And it's going to appear to be a solution, but when you go to check your answer, it will not satisfy. It will not equal the right-hand side. And so let's go ahead and see what that looks like, okay? So we once again look at number 4. Is it isolated? The answer is yes. So we have 4x plus 10 is equal to 6x. And then we've got 4x plus, and you know what I'll do is I think I'm going to zoom in a little bit so I can get some more space. So bear with me, guys. Let me zoom in real quick. Okay, there we go. So I've got, once again, 4x plus 10 is equal to 6x. And then I've got 4x plus 10 is equal to -6x. So we're going to go ahead and solve for combine like terms and solve for x. So I'm going to bring the 4x over to the right-hand side. So I'm going to subtract 4x. So that gives me 10 is equal to 2x. And then we're going to divide by 2, and x will equal 5. So that's my first possibility, okay? Now, moving over to the right, I'm going to subtract 4x to the other side. I get 10 is equal to a -10x, okay? Divide by 10 on both sides, -10 on both sides, and I get x is equal to -1. So as you can see, we solved for 2 possible answers, but one of them is not going to work. So we plug it in as always. So absolute value of 4 times 5 plus 10 is equal to 6 times 4. Or not 4, 5. There we go, 6 times 5. So we have 4 times 5, that's going to give me 20 plus 10, that'll equal 30. And then we have the absolute value of 30 equals 30. Now, of course, that one's going to check out, and so we're good to go. Let's go ahead and verify the other side now. Okay. So I've got, and I'll use a different color. the absolute value of 4 times -1 plus 10 is equal to 6 times -1. There we go. So let's go ahead and solve for this. 4 times -1, that's going to be -4 plus 10 is equal to -6. Now, -4 plus 10, that gives us absolute value of 6, but what you'll find out is that the absolute value turns everything positive. So 6 can't equal -6. So this is not a solution. Only x equals 5 is. Okay? So that right there is a good example of what to expect for extraneous, okay? So let's go ahead and take a look at this one over here, okay? I know I kind of ran out of some space, but we'll use this space off to the right. So I've got my 2x, and nothing's around him. All the absolute value looks good, so let's go ahead and write our two equations. So I've got 2x plus 12 is equal to 4x. And then, of course, we got to make the other one negative, so let's go ahead and do so. So I've got 2x plus 12 is equal to -4x. Okay, so with that being said, we're going to go ahead and start solving. I subtract 2x to the other side, and I got 12 is equal to 2x. X is going to equal 6. So that one works out. Then on the other side, I'm going to subtract 2x to the other side. I got 12 is equal to -6x. And that's going to give me x is equal to, I believe, a -2. So now let's check our answers. And so we've got the absolute value of 2 times 6 plus 12 is equal to 4 times 6. Okay, that's going to give me, in the end, 12 plus 12 is equal to 24. And the absolute value of 24 equals 24. That is a true statement, so that one's good to go. Okay, let's take a look at the next one. And I end up with gotta get my pen. Absolute value of 2 times -2 plus 12 is equal to 4 times -2. So 2 times -2 is going to give me a -4 plus 12, and that's going to equal -8. But then when you find out, when you simplify, -4 plus 12, that gives you -8 inside, or not -8, but +8 on the inside, is equal to -8. And of course, this absolute value is not going to work out because it changes everything to a positive number. So what we're going to end up with is 8 is not equal to -8. So this one right here up top is an extraneous solution. That is not a solution. So we only ended up with 1 again. Alrighty, so I'm going to show you one last final example, so that way you've seen one of these before, and then this will be the end of the note. So let's do our last example. Alrighty guys, so here's the last example. What we're going to go ahead and do is we're going to verify whether or not the absolute values are isolated, and they are. There's nothing around them, so they're good to go, okay? What we're going to do is split it down the middle as always, and we're going to write two equations. Okay, now the right-hand side, we make it negative, but when we do so, we got to make the whole thing negative, meaning I got to multiply the whole expression, okay? So then I distribute my negative into each one of these terms, and I'm left with x plus 5 is equal to -x minus 11, okay? Now, the left-hand side, let's go ahead and solve it all the way through. I subtract x to both sides, and these add up to 0, leaving me with 5 is equal to 11. Well, is that even a true statement? No, so that one's actually already done. No need to press forward on that one. But let's check the right-hand side. I add x to the other side. I've got 2x plus 5 is equal to 11, or -11. Subtract 5 to the other side, and I've got 2x is equal to -16. So x will equal -8. So let's go ahead and check whether or not he is indeed an answer. So the way I do that is I have the absolute value, and I'll use a different color. The absolute value of -8 plus 5 is equal to the absolute value of -8 plus 11. We solve for that. That's going to give me a absolute value of -3 is equal to the absolute value of +3. Well, what we find out is that anything inside the absolute value changes it to positive. So 3 equals 3, and that is good. And this answer is good. So we had one extraneous where it just didn't work out, but we did have one answer for this one. Alrighty, guys, that's it for the notes. Thank you guys for tuning in. All right, bye.